So in this video, we will be solving this integral right here, and the approach that I will be using is integration by parts, but I'm going to assume that you are already familiar with how integration by parts work, because that's the basic thing, all right? The advanced thing about this integral here is that we have to use a specific method in which we can solve this using integration by parts, because if you noticed, the basic rule of integration by parts is that you have to reduce at any one term to a constant expression, but over here we cannot reduce either e to the power 3x or cos 4x to a constant expression. And whenever you face such an integral, you just have to remember this method which I'm about to tell you in order to solve it. So for this method, all you need to do is you need to equate this to any random variable or number. No, actually any random alphabet. So let's say it's like I. All right, so I'll say that the answer of this integral is equal to I. Now, why did I do that? I will explain later on as we progress with this video. So let's start, and I am going to differentiate this and integrate this. It's actually completely up to you in this integral right here, but I just feel like doing this, which is why I will. So I is equal to, now e to the power 3x will come as it is, and the integral of this expression right here is actually sine 4x divided by 4. Minus, now let's just differentiate this thing right here, 3e to the power 3x multiplied by, dot means a multiply, so sine 4x divided by 4. Let me just rewrite this properly, e to the power 3x sine 4x divided by 4 minus 3 by 4 integral of e to the power 3x sine 4x. Now I have to resolve this. What I'm trying to do is I want to get this integral here back. So I will keep on solving all of this using integration by parts until I get this expression back, and that will help me to solve this integral. Let me explain what I mean. So let's just solve it, and I hope you guys will understand what I'm trying to say. Sine 4x by 4 minus 3 by 4, and let's just resolve this. So we'll be applying integration by parts once again, and we get e to the power 3x, and over here we get minus cos 4x by 4. All right, so yeah, over here we'll get 3e to the power 3x because we took the derivative, and minus cos 4x by 4. Fine. So yeah, let me just close the brackets and let's just move on. I is equal to e to the power 3x sine 4x divided by 4 minus 3 by 4 integral of minus e to the 3x cos 4x by 4, and here we can just take this as common, minus 3 by 4, minus actually cancels out, so this will be plus 3 by 4 integral of e to the power 3x cos 4x. Now if you notice, we have the same expression as we did earlier on in the question, right? And this will be really essential for us. Why? It's because if you recall, I said I is equal to this, which means the answer of this integral right here should be I. Now I can resubstitute that, and that will make my life a lot more easier, because if I do not resubstitute it, this integral will go on forever. It will take forever and it will not solve. So I have to resubstitute this, and I have to say that let's assume the answer of this is I. Now let me show you how that will allow me to compute this integral. So I is equal to e to the power 3x sine 4x. Let me just quickly write this. And cos 4x by 4 plus 3 by 4. Now instead of this, I will be writing I. So yeah, I'll just write it like this, and let's just expand all of this expression. E to the 3x sine 4x by 4 minus, now this becomes 3 plus 3 by 16 e to the power 3x cos 4x, and this becomes minus 9 over 16 I. Now obviously we will just take our I and just take it to the left hand side. So this becomes I plus 9 by 16 I, which is equal to e to the 3x sine 4x by 4 plus 3 by 16 e to the power 3x cos 4x. Now let's just, when we compute this using LCM, I'm pretty sure this will be 25 by 16. So let's just see, multiply by 16, multiply by 16. Yeah, 16 plus 9 is 25. So 25 by 16 I is equal to all of this. So I can just directly bring 25 by 16 to the right hand side, which will be 16 by 25. Does that make sense? Because I just skipped one step because I would have, otherwise I would have to write it all over again. So e to the power 3x sine 4x by 4 plus 3 by 16 e to the power 3x cos 4x, and the limits were 0 to pi by 2 stated in the question. So yeah, when we compute this, let's just compute it real quick. We get, now sine of 4 multiplied by pi by 2 would be sine of 2 pi, which is 0. So I'll write this as 0. And over here, cos of 2 pi is actually 1. So this will be written as 3 by 16 e to the power 3 pi by 2. And minus, when we substitute 0, this becomes 0 because sine of 0 is 0. And cos of 0 is actually 1. And e to the power 0 is also 1. So plus 3 by 16. That was just mental math. And 16 by 25. And inside we'll be writing 3 by 16 e to the power 3 by 2 minus 3 by 16, which becomes our final answer, which if we compute it, it would be 16 by 25 into 3 by 16 e to the power 3 pi by 2 minus, wait, let me just compute this real quick, minus 3 by 16. So the numerical answer for this is 13.238, and that's how you solve this integral. So the main thing that we needed to know was that if we have such expressions which cannot be simplified into a constant expression, what we need to do is that we have to equate it to any random alphabet. For me, I just chose I. You could have chosen it to be A, B, or whatever you want. All right, and once you get this expression back anywhere in your working while applying integration by parts, you just resubstitute this over here and you just take that to the other side, and then you can just easily compute your integral using integration by parts.